My name is Doug Simmers, and I'm product manager for Rosemount Analytical, one of the Emerson process management teams. Oxygen analyzers have been used for decades for controlling fuel-air ratio in any combustion process, such as a large boiler, process heater furnace, or even automobiles. Today I'm going to talk about a particular application that has challenges of its own. This is the rotating kiln. Okay. Here we have a rotating kiln in a pulp and paper mill for processing lime. Okay. The process is very similar between lime and also cement. Okay. Here's a graphic representation of a kiln. We can see here that a kiln is really just a large tube, as much as 20 feet in diameter, tilted a little bit, and the entire tube rotates. We feed in your initial process, which is usually limestone that's either fed in as a slurry or as a crushed stone, and then this lime tumbles as the kiln rotates from one end to the other, because the kiln is tilted at a slight angle. Okay. We have a fire that fires from the opposite end, and that's what heats up the lime and calcines it, either into lime or cement. The product drops out at the other end. For measuring oxygen in this kiln, many times people will take an analyzer such as this, a long one, and extend it all the way into the kiln, and other times they'll put it just into the core of the flue gas coming out of the kiln. One of the challenges in a kiln is that since it's rotating, we have air that gets sucked in to the kiln at both ends where it rotates. They use leaf seals to prevent this biasing of the O2 measurement upwards. Here we have a view from inside the kiln as it's been shut down and they're working on it. And we can see here that we have the actual feed tube feeding the product in, and a 12-foot long in-situ oxygen analyzer, and then also a thermocouple. Okay, these are the leaf seals. So we're in the rotating portion here, and the stationary portion is beyond. Some of the kilns operate at temperatures that the analyzer can withstand, which is around 700 degrees C. And other ones operate at a higher temperature. So we do have a heat rejecting jacket that can be used to raise the operational temperature of the analyzer to as much as 1,000 or 1,100 degrees centigrade. So basically this is a quick overview of measuring oxygen for optimum fuel-air ratio, also for optimum safety, and you can also infer the calcining rate of your product as it progresses through the kiln by use of temperature measurements in addition to the O2 measurement. Thank you very much.